Here we are for the week 20 test. Remember, this is an opportunity for you to go through the problems you had difficulty with, look at them again. You're going to see problems similar to these come up in the next several weeks. That's the great thing about this program. If you miss it the first time, you have a chance to revisit it, a chance to go back and check it again and improve what you know, show what you know, make those grades go up. All right, problem number one. This is a surface area problem. They're giving us a playhouse, and they're telling us that we need to figure out the surface area of that playhouse so that we can paint it. The paint's going to cover 125 square feet for every can of paint. When we get to that point, each can, 125 square feet. First, we need to find out the surface area. So as we discussed in class, we divided the house into 4 parts. We divided it into the parts based on the shapes. So there's a rectangle for number 1, or excuse me, a triangle for number 1, a rectangle for number 2, a rectangle for number 3, and a roof that is also a rectangle. Now for this problem, unlike some of those we looked at in class, you're going to paint everything the same. So the roof is going to get painted with the same paint that the walls are. But we're still going to figure out the roof separately, just so we're sure we know how to do this. So let's go back and let's start with that triangle. So we're going to start with this first triangular piece. Here is the math for that. We have 10 times 3 divided by 2. That's the base of 10 times the height of 3. We get 30 divided by 2 is 15. Let me get rid of that shading. And then we multiply that by 2 because there's a triangle at that end, and you can't fully see it back here, but there's another triangular piece. Goes across like so. It's hidden at the end of the house. So you have 2 triangular pieces. Each of them have an area of 15, so all together they have a surface area of 30. All right, let's get rid of those triangular pieces, and let's take a look at the next section. Then we have a rectangle. We have this rectangle right here, number 2. It is 10 by 3, so that's going to be 30. And again, we multiply by 2 because we can't see it, but right down at this end of the house, there's another rectangle just like it making up the other end. So we have that twice. We're going to see the same thing happen with our next shape. Our next shape, number 3, right here. It's 18 by 3, so 18 times 3 is 54. And there's another one like it right over here in the house. There's another one back here on the other side, opposite side, so that's why we multiply by 2 again. And then finally the roof piece. We've got this section of roof. It is 18 by 7 for a total of 126. We have to multiply it by 2 because there's another roof piece right on the other side. So then we put together the ones that we're going to put together. We're going to put these 3 together, the 30, the 60, the 108. Did that right here. Get 198 total for the surface area of the walls. We also have the piece of roof right here. That's the 252. We add all that together, we get 450. And that's 450. Let me add a label to that because I should have done it when I first wrote it. That is 450 feet squared. We divide that, 450, take that right up here, divide it by the 125, because that's what they told us right back here in the problem. Every can covers 125 square feet. We get 3.6. That has to round up to 4 cans. We discussed this several times in class. Anytime you have more than a full can, doesn't matter how much more, you have to round up to the next can. All right, so go back, review that if you'd like to. You'll be able to look at these answers online, and if you need to, you can listen to parts of the video again. On to number 2. The Walton family, they have a pool. They have maybe grown in size. Maybe the family's gotten bigger because this pool is no longer big enough. So they want to replace it with another pool that has an area about twice as big. About is a key word here. That tells you you're not going to get exactly that answer. You're going to get something that's in that range. So the first thing we need to do, you saw here when we discussed this in class, I wrote down this is the starting point. Starting point is figure out how big is the current pool. Because when somebody says twice as big doesn't mean anything unless you know what the original looks like. It'd be like somebody saying, would you like twice as much money as what this kid has or that kid has? And you'd want to ask first, well, how much do they have now? Because I want twice as much as the kid that has the most money. So we have to start here, and we have to work through the original pool. They told us it had a diameter of 18, which means it has a radius of 9. So we're going to be doing 3.14 times 9 squared, which is 3.14 times 81. I'm right here. And that gives us 254.34. When I double that, twice as big, double it, I get 508.68. That's my target amount. I'm looking for 508, thereabouts. So then I go through and I find the area of all my pools. And I'm not going to do each one of these because I think you can see the work. I'll do the one that worked. It's 3.14 times 13 squared. Now the question popped up, where did I get the 13? Got it right here. If the diameter, anytime they show you this, they're saying all the way across this pool, all the way across is 26. So the radius is 13, and radius is what we use when we do area. So 3.14 times the radius squared is 3.14 times 169. It's 530. That ends up being the closest. You can see the sizes of these other pools, 452.16. 706.5, that's almost 3 times, and then we get 1,017. That's a huge pool. The Waltons won't need that one for a while. All right, so there's number 2. Again, go back, review it, try to do the math. Shut the video off or pause it and put your head down and try again. See if you could solve it yourself, because you're going to see problems like this coming up later. On to number 3. Number 3 is a stepping stones problem. We've seen this a couple times now. So Tom is shopping for stones. He's going to be looking for 2 sizes. He's going to be looking either for a size that's 100 to 115 or a size that's 200 to 215. And just like the last problem, they show us diameters. We need to get the radius. I've done all my work down here for each of the stones, and I would encourage you, really show your work. Not only to get the credit, because if you don't show your work, I don't give you full credit, but more important, show your work so that when you have a mistake, when something doesn't work, you have a way to go back and figure out what you did. If you just do it on a calculator and write an answer, and then you wonder, well, what mistake did I make? Did I punch in the wrong number? Did I not understand the problem? For example, in A here, did I look at 4 squared and accidentally go, oh, that's 4 times 2. Did I have an 8 there when I punched it in my calculator? Well, if you write it down, you'll know what you did. If you don't write it down, well, then it's really hard to go back and help yourself analyze your work. So we go through, we figure out the area of each of these, and the 2 that work are right here. B goes into the 115. That's between the 100 to 115. And C is in the 200 to 215 range, and nothing else fits. So those are the 2 that you would be able to sell Tom. If you're selling them, Tom's buying them. All right, number 4. So Julie's making a rectangular frame. Now this is one where you do a lot of working backwards. So they tell you the perimeter is 120, and they tell you that the length is 40. Well, if that's a 40, then that's a 40. So you've got 120. Here's the work for that. You've got a 40 and a width and a 40 and a width. That means you have 80 plus the 2 widths equal 120. Take away the 80. We get the 2 widths equal 40, or the width is 2. Now, you might not have done it that way. You might have looked at it and said, well, I know 40 and 40, and so 120 take away that 80 gives me 40, and that's 2 of these pieces, so I'm going to divide that in half. I'm going to get 20. You did the same thing that I did. Mine just looks more math-like, more formal. You don't have to have done it the way I did it. You just had to get the right answer. So now you've got that width is 20. Now we go back up, and it tells us that The sun is framed with copper wire that has a diameter that is half the width. So if the width is 20, the diameter is 10, half the width. And if the diameter is 10, then the radius is 5. And the radius is what we need to do the circumference of this circle. So we get the circumference. Here is our work for that. There's our work with the radius we used. We get 31.4. That is the radius here. That's how much copper wire got used. We already knew that the silver wire being used was the frame itself. That's the 120. So the 120, take away the amount of copper, 88.6. All right, that takes you through all those problems. Here was the extra credit. The extra credit problem you had to locate. This is the point right here, 6.5. That's the center of a circle. If that's the center of the circle, then this is a radius out to that point, 1, 2, 3, 4. And you'd have a radius equal to 4. And you put that into the formula 2 times pi times the radius, and that's where we get 50.24. So now you've had a chance to look at week 20. Go back and review it. Check it against your work. Remember, this is that opportunity to study before the next test when you see similar problems so you understand how to do them before you sit down on Wednesday to do the work. As always, if you have any additional questions, be sure to give me those questions. Bring them to class. We can discuss them in class. We can discuss them at SSR. We'll answer your questions if you're willing to take the time to ask them.